Hi everyone. Let's take a few minutes to talk through some of these homework problems. So far we've only worked on the odds, so that's what this video will focus on, and then after you're sure that you're doing well with the odds, you can go back and try the evens. So taking a look at the first one, we talked about this in class, but anytime you're doing the limit of just a constant, that's a really easy answer. Okay, a constant is always constant. So the limit as you're approaching any x value is just going to remain that same function value. So this limit is 12. It doesn't even matter that it's approaching 5. Whatever it's approaching, the limit's going to be 12. Okay, jumping down to number 3. Remember, my first plan of attack would always be to just plug this x number in and see what happens. So in this case, that's exactly what I'm going to do. I'm just going to say, okay, let's do 4 times 2, and I get 8 as an answer. And we could graph this and take a look at it, and this function would contain the point 2 comma 8. And so since this function is continuous, there's no holes or gaps or anything in it, then the limit is just the function value. I think something similar is going to happen here with number 5, because I don't see any potential for discontinuities here. So when I put negative 1 into the 4th power, that's going to leave me with a positive 3 minus negative 1 to the 3rd will stay negative, so this will become a negative 6 minus, and then 2 times negative 1 also leaves me with a negative, so negative 2. So that's really 3 plus 6 plus 2, which is 11. Okay, getting maybe a little trickier with number 7, but the first thing I would always try still is let's plug in that negative 2. So if I plug in the negative 2 on the top, negative 2 squared is 4, plus, let's see, negative 2 times 4 is negative 8, and then plus another 4. Okay, so I'm seeing a 0 coming out on top here. We're not nearly as worried about the 0 on top as we are on the bottom, but let's just make sure we do the bottom as well, because if we end up with a 0 over 0, that's where we have an issue. But negative 2 squared is just positive 4, which means this is 0 over 4. Okay, 0 on top just means that this thing is equivalent to 0. Like this whole answer is equal to 0. So that's not a discontinuity, that's just a limit of 0. Okay, we got to get some hard ones in here. Let's take a look at number 9. So when I crunch the numbers here on number 9, 4 squared minus 16, that's really 16 minus 16, which gives me a 0 on top. And 4 minus 4 on the bottom is also giving me a 0. So this is one that's giving me a 0 over 0. Okay. And so what I'm going to do with this one is I'm going to move off to the side, and I didn't leave you a ton of room underneath. That's usually where I prefer to do this, but I'm going to take this thing off and just kind of work over here with it. X squared minus 16 can factor. Just so you can see what I'm doing here, I'm going to write this. So x squared minus 16 factors into x plus 4 and x minus 4 all over x minus 4. And then those x minus 4s are going to cancel, but that means that what I'm really left with is just the x plus 4, and that allows me to rewrite my limit statement over here. And that is a habit that I really want you to get into. Wouldn't matter if this was like a multiple choice question, but if it was a free response, this is how you should show what you're doing here. So we're going to say this is the limit of just x plus 4. And now I can plug my 4 in here, and I get a 4 plus 4, which is 8 as a final answer here. Okay. So what that is telling me is this function would actually, oh, I'm sorry, I pointed at the wrong one. This function would have a hole at x equals 4, but that's okay. Just because it has a hole, like that's a removable discontinuity, and that means that I can find a limit still. Okay, let's take a look at number 11. I'm guessing a similar thing is going to happen. So again, the first thing I would do is plug in your negative 1. That's going to be 1 plus negative 6, so that's negative 5, and then plus 5, that gives me a 0. On the bottom, I have 1 minus negative 3, which is positive 4, and then 4 minus 4 gives me 0. So sure enough, this is another one where when I plug my values in, I get 0 over 0. And so I'm going to work off to the side and try to simplify this expression somehow. Okay, so let's take that top expression, the x squared plus 6x plus 5 over x squared minus 3x. I don't know that it's really necessary for me to rewrite the whole thing. I'm really just doing that for your benefit so you can see where this is coming from. So if you did not rewrite it, that's okay. But we should definitely show what's happening here. And what's happening is this is factoring as x plus 5 and x plus 1, because that multiplies to 5 and adds to 6. And then this is going to factor as x plus 1 and x minus 4. So my x plus 1s are going to go away, and that's what's canceling out my discontinuity at -1. So the function that I'm left with now is x plus 5 on top, x minus 4 on the bottom. And now that allows me to plug in my -1. So when I plug in -1 on top, -1 plus 5, I get a 4. On the bottom, -1 minus 4 is -5. And so my final answer there is -4/5. It kind of got squeezed in there funny, but that would be my limit, is -4/5. Okay, let's move on to the back here. So looking at number 13, okay, this is kind of going back to some stuff that we did before. We're trying to find a limit at 3. And a lot of you are wanting to say, well, we can just plug it in here because that's where x is equal to 3. But remember that with limits, we have to be concerned about what's happening on the left and the right. And this function breaks apart at 3. Okay, 3 is the place where these two functions are coming together. So I'm going to need to look at a left-sided limit and a right-sided limit to know if my limit really exists. Okay, so I'm going to start by saying, what is the limit as we're approaching 3 from the right of this function? And when I'm doing my right-sided limit, I want to look at the x values that are to the right of 3. So that's this guy. Okay. And then I'm going to do my limit as x is approaching 3 from the left of f of x. And so for the left of 3, I'm using this function up here. Okay, so for the right side, and both sides are going toward 3, so I'm going to say 2 times 3 minus 3. That's 6 minus 3, so this is 3. From the right side, I'm sorry, this is from the left side. I may have misspoke there. This was from the right, so this is using the 2x minus 3. This is from the left, so I'm going to use the x minus 1. So I'm going to say 3 minus 1, which is 2. And so the issue I run into here is this function does not meet. Like when I'm at 3, one side of the function is stopping at y equals 3 and one side of the function is stopping at y equals 2. And so what that tells me is this limit overall does not exist. Okay, let's try the next one here, number 15. So let's do the same thing. So this is a piecewise function. The piecewise functions are the ones where you have to think about left and right limits. Okay, so I'm going to say what is happening with this function when you go toward -1 from the left, and the left side of -1, that's what's happening right here. So this is what I'm using for my left function. And then I'm also going to say what is my limit as we're approaching -1 from the right. This is what's happening to the right of -1, so this is the right side. Okay, so let's plug -1 into the left side. So that would be, actually here, I'm just going to write f of x, and then I'll fill the number in a second, sorry. So this should say f of x. This should say f of x. And then this I'm going to say, okay, let's do -1 squared plus -1. Down here, I'm plugging -1 into the right side, so I'm doing -2 to the power of -1. Okay, so -1 squared is +1. plus another negative 1. So this thing's going to come out to be 0. This is really negative 2 to the power of positive 1, which is just negative 2. And so then once again, we've got right side and left side that do not match. So my overall limit here does not exist. Okay. Let's move on to 17 here. So 17, this is one of the ones that we didn't necessarily learn this one, but we learned one that's really similar to this. This should look very familiar to you. This was one of the functions that I told you to just straight up memorize, okay? And what you should have memorized is that the limit of sine x over x is always 1. Again, later on, we're going to learn a technique that you could use to find that answer if you didn't remember that. But for right now, memorization is your friend, okay? Now that 5 might be bothering some of you. So here's what I'm going to do. I'm going to take this function off, just like we've done with some of the others. And I'm going to say, well, this is really the same thing as 1/5 times, oh, I didn't leave myself enough room, sine x over x. So all I really did was take that 5 out of there and make it a 1/5, okay? But the thing about that is, remember that constant multiple rule is if I know this limit, I can just take the limit and multiply by 1/5. So I could say this is really the same thing as doing a limit as x approaches 0 of, and I guess I probably didn't need to write it separately over here because I'm just rewriting it here, of sine x over x, okay? And so then when I do that calculation, I can say, all right, that's 1/5 times the limit that we already know is 1, and so my answer here would just be 1/5. Okay, so we can sneak little numbers in there. All you have to do is pull those numbers back out of there. Okay, I'm guessing number 19 may have thrown you for a loop a little bit, but I want you to pay really close attention to this statement right here, okay, because this is what we're going to kind of do our work based on. What's happening here is we have a function that mostly looks like this. This would be a parabola, x squared minus 2x minus 3. But for whatever reason at x equals 2, someone came along and... So when we want to find f of 2, that's this thing, right? So this right here is how we're calculating f of 2. Everywhere else in this function we're using this thing, but this is telling us what is the actual value at x equals 2. So I want these two things to be the same. Well, the limit as x approaches 2, that's going to be this function, because this is what's telling you what's happening everywhere except right at 2. Okay, this is telling me that I have a hole in my graph. But as far as limits concerned, I don't care about the value in the hole. I care about what the y values are doing to either side of that hole. Okay, so this limit right here can be calculated by just plugging 2 into this function. So I'm going to say, okay, let's do 2 squared minus 2 times 2 minus 3. And I want that to be equal to f of 2, which we already said is k minus 3. Okay, so that's f of 2. So see what I did there is I just translated this very literally into an equation. Okay, so this is now 4 minus 4, which is 0, and then 0 minus 3 is negative 3. So I have negative 3 equals k minus 3. Okay, hopefully the answer for k is jumping out at you right now, but if you needed to, you could think of this as like, oh, I'm adding 3 to the other side, but we end up with just k equals 0. So in tonight's assignment, you're going to try that with this problem here. It's going to work very, very similar. Pay attention to like how this statement is written. It's the exact same type of setup. We've punched a hole in the graph, and for whatever reason, we're using this other function, but you can just use that and set it equal to your limit from up here. So, okay, hopefully that helped you with anything you were struggling with these problems. If you run into anything else, we'll be sure to talk about it when I see you tomorrow.